Now we'll look at how we can switch between the parametric equation form and the rectangular form, if possible, for a particular set of parametric equations. I think it's actually easier to learn how to go from parametric equations into rectangular equations first, so that's what we'll learn how to do in this video. So basically this is based off of the substitution method. You solve one of the equations for t, and then substitute that into the other equation, and that's effectively all you have to do. So for instance, in this next example, we have x of t equals t squared minus 3, and y equals 2t plus 1. All right, so the endpoints of the domain for t do translate to endpoints of the domain for x and y, but often you're really just concerned with switching the form. So let's not worry about that at this point. In order to switch this form, we would just choose one of the variables to solve one equation for t. So I'll pick y, because it has a linear variable t. So y minus 1 equals 2t, so that t is defined as y minus 1 divided by 2. Now I can take this equation and substitute that in for the variable t in the x equation. So now I can say x is equal to y minus 1 over 2 quantity squared minus 3, and this is a perfectly fine representation. If you want to leave it like this, that's okay. Your instructor may want you to continue solving a little bit more, like certainly it would be easy enough to square the fraction involved here. But this is a perfectly fine response. So it's a function x in terms of y, but that's okay. It can be that. It doesn't have to be y in terms of x. If we had solved x for t and then substituted into y, that's what we would have ended up with. But it would have been a little trickier because we would have involved a square root. In the next example, eliminate the parameter for the plane curve described by the following parametric equations and describe the resulting graph. All right, so the parametric equations here, I have x equals the square root of 2t plus 4, and y equals 2t plus 1. And you may have noticed that I'm not writing x of t, I'm just writing x. It's perfectly okay. Just because a function doesn't have, just because a variable doesn't have the set of input variables doesn't mean it's not a function. It's all about how we define it. So if I define this thing as the square root of 2t plus 4, that clearly defines a function because of the parentheses. But even if I didn't have this, this declares x as a function. The variable is inherently understood to be t because that's the variable involved. And this is perfectly fine. So don't worry about me not including the t in parentheses versus including it. Process is the same. I think I will maybe this time solve the top equation for t. So what I would do is first square both sides of this equation, and that's going to give me x squared equals 2t plus 4. If I subtract 4 from both sides, I would have x squared minus 4 equals 2t, or t equals x squared minus 4 divided by 2. And then I can take this knowledge for t and substitute that in for t in the other equation. So that would give me y equals 2 times x squared minus 4 over 2 plus 1, which would essentially be x squared minus 3. And I'm not going to draw the graph, but it says to describe the graph, so I'll do that. This would be a parabola, and it would be opening upward, but shifted down 3 units. All right, our last example here. Eliminate the parameter for the plane curve described by the following parametric equations and describe the resulting graph. Okay, so I have x equals 4 cosine t and y equals 3 sine t. And t is on the interval from 0 to 2 pi. Now, in order to work with these types of parametric equations and change them into rectangular form, one thing that I find easiest to do is square both sides of the equation. Okay, for both equations, that is. And then we have x squared equals 16 cosine squared t. Well, let me get my square in there. Which would give me x squared divided by 16 is cosine squared t. And likewise, I would have y squared divided by 9 equals sine squared t. Now, using the Pythagorean identity from trig, cosine squared t plus sine squared t is equal to 1. I can now just substitute what I know for cosine squared t, which is x squared over 16, and for sine squared, which is y squared over 9, which equals 1. And based off of that transformation, I can tell that this graph would be an ellipse. And you might not be incredibly comfortable with that, but this is a perfectly viable method of changing these equations into a rectangular form. You certainly could do it without using the Pythagorean theorem. So for instance, I could solve the top equation x for t, but that would involve an arc cosine, and then I would have to plug an arc cosine over into the function sine, which would take a little bit more trigonometry to reduce. So this really is the preferred method. It's much simpler than the alternative.